Hi everybody, welcome back to the Tetrix RoboBench video series. This is Tim from Pittsco Education. In today's RoboBench, I want to talk to you about something that happens to all of us in our robot building career. And that's when you have a part fail. And that's going to happen to you. And if it hasn't already happened to you. So I want to talk about that so that we can learn to look at that in the correct light, because there's an opportunity here in an educational context on understanding how things work better when we look at part failure in the proper light. So let's start with an obvious example that hopefully will kind of illustrate my point and then allow us to give us something to talk about as we go through this. So I have an example here, an obvious example that I've kind of exaggerated things, hopefully so you'll be able to see what I've got going on. But I've got a wheel mounted on a channel, on an axle, and you can see there's some obvious issues here. The axle is bent. My wheel is worn on the inside, and because it's bent and worn, it's been wearing because it's rubbing on this plate on the top, which has even caused the plate to bend. So I've got three different points of failure here. I've got a bent axle, I've got a bad wheel, and I've got a bad plate. But the reality is that all three of those failures were probably caused by another issue. There's symptoms, but they're not the actual cause of the problem. The cause of the problem is not the quality of the part. The cause is the fact that I probably have got too much weight or load pushing down on these items that's caused the axle to bend, that's caused the wheel to be out of alignment, caused it to wear on the inside, and caused it to contact this plate and bend the plate. So again, we've got something going on here besides just part quality. There's an obvious knee-jerk reaction, if you will, of those of us that are not used to a system and don't understand to say, oh, I'm going to blame the problem on that quality of the part. I just need a better quality part and it wouldn't fail. Well, that could be due to a certain extent because parts all have a quality standard or a parameter that they're designed for. Now, the important thing to understand is that whenever we use a part outside of those design parameters, it's going to fail. Doesn't matter how much you pay for that part or where you get it from, who makes it. They've got those design parameters for a reason, and if you go outside of those, if you use something in a manner that it's not been designed for, the likelihood of failure of that part is going to go up 100%. At some point, it's going to fail. So we want to be able to talk about why that is and make sure that we understand that in order to reduce frustration, we need to understand that. So let's talk about, again, some of the symptoms that occur that allow us to kind of begin to identify the fact that maybe we've got something going on here besides just the simple failure of a quality issue with a part. Let's talk about repeatability and the fact that, or frequency of failure, so that if I have a system that I built and I see a wheel fail one time. Now this is, again, let me make sure I point out the fact that we're talking about normal operating procedure conditions. We're not talking about a catastrophic failure. We're not talking about a drop from the top of the roof, or we're not talking about your car that you backed over your robot and you had a part failure there. We're talking about normal operating conditions. In those conditions, if you begin to see a frequency of events, so that I have an axle fail one time, that might be a simple exception to the rule. I replace the axle. It fails again in the exact same way. That's a sign, beyond the obvious, the fact that the axle's bent, that I've got a problem going on. So that's when we begin to say, okay, I need to be able to identify what's going on so that I can go ahead and fix it. If I look at this and I say I've got a bent axle, and I've realized I've identified the fact that that's what's going on and there's frequency going on there, I can look at this as an opportunity to then, okay, let me go ahead and take this opportunity to maybe improve my design, improve my performance by fixing the problem. If I go ahead and support this on the outside, on two sides, so it's double sheared, Then all of a sudden, that axle might not bend under the weight. I don't have to change the weight. It'll support it correctly. The wheel won't be canted over. It won't rub on the inside, and it's not going to damage this plate. So again, there's an opportunity there for a learning and improvement of design to go ahead and fix the problem. So again, why does this matter for us? Why should we care? Well, the fact is that to be better engineers, we need to care. It's going to, number one, allow us to manage our resources better. It's going to reduce our frustration level. And again, it's going to cost less at the end of the day. And those are important reasons why we need to look at part failure. And we need as an opportunity to go ahead and say, let's fix that. Let's go ahead and make an improvement. Let's not just blame it on the quality of the part. Let's go ahead and take this as an opportunity to, number one, learn and then also improve, because that's important for us. Takeaways, again, this is all about becoming a better engineer. Now, let me back up a minute and say, because I want to point out that there are times in your engineering life that you're going to make a conscious decision to say, you know what, I'm going to sacrifice one part. I'm going to put in a part that I know is going to fail in order to protect other parts. A good example of that is our batteries and the fact that we put a fuse in the line of our battery because we want the fuse to fail before the battery fails. Batteries are expensive. Fuses are not. So the idea of the fact that we intentionally put a part in that could fail before the more expensive part fails is a sound engineering decision. And those are the type of things, but you have to make an informed decision. And that's the important part too. In your engineering design, if you put your fuse in line to protect your battery, but then you, as part of your design, put the fuse and the battery in a location that it's hard to get to in order to replace, that's not a very good choice either. So you need to make sure that you understand that there's times that it is very appropriate to use a part that you want to fail to protect one, but then you need to account for that and allow for that. So there is a part of that becomes then a conscious choice. But the idea is, again, takeaway, this is going to make us a better engineer. This is going to reduce our frustration. This is going to allow us to make more informed decisions, a better learning experience, and again, a better use of resources. So I hope you found that information to be helpful to you in your robot building life. I hope that you'll be able to go ahead and take that and apply it and understand that, you know what, let's not have that knee-jerk reaction that says, okay, these are just a bad part or poor quality. Let's use it as an opportunity so that we can go out there and build better robots. So like we say, have fun, build some robots, and come back and see us.